Hi, welcome to Wednesday. Hope you're all good and hope you're all ready to do some maths. Composite functions. I noticed the other lesson that Jess was already working through this, so she'll be an expert, so it'll be a bit of revision for her. So going back to primary school, do you remember function machines and input and output machines? So basically we're going to start off with that. So if you think about it, if we have an input of 3 and we have an output of 11, here's our function, and you can probably work out from that our function is going to be x squared plus 2. Now, our domain and our range. So the domain of this function is our input. If you think about it, that's our domain. If you think about it as a graph, our domain is our x values. Range is the output of this function machine, and the range is our y value. So they've set this function machine up so the domain and the range kind of are reflective. The ideas are similar to an x and y axis. So now we add another one, another function. Function f, function g. So this function f is the same. Function g, slightly different. And as I just accidentally clicked, you probably already saw that the function for g is x squared. So the domain of f still goes in to the function machine f. The range of f still comes out of the function machine f. But you can see that the range of f becomes the domain of g. So that the range of this function becomes the domain of this function. That is the crucial bit. That is the bit you're going to need to remember. You're going to need to know. It's going to confuse you to all those sort of things. But here we are. Hopefully you can just see that. And the range of g, the output of g is just the range of g. Notation and stuff. So the new function h is said to be the composition of g with f, written as h equals GOF. You'll probably call that GOF. Composition of f followed by g, h of x equals g of f of x. Lots of different ways that we're going to say the same thing. So in the US, in America, on Thanksgiving, they'll often have a turducken, which is basically a chicken inside a duck, inside a turkey. Don't ask me, never had one. So basically the concept is that one thing is inside of another. So this G machine inside the F machine. You see it's written here, sorry, the F machine is inside the G machine. You can see it there, it's inside. Another way to look at it is you've got a duck inside a dragon, and that duck is laying an egg. So the egg is inside the duck, and the duck is inside the chicken. So I think you're going to watch a couple of videos in a minute, and they'll be using this analogy, but this analogy is just explaining that one thing is inside another, and when it is, you've got the range of one becomes the domain of the other. For those of you that like some visuals, here's some nice visuals. So here we know that GOF can be written as G of f of x, and we know here's another one, the domain of the composite function will be the domain of the original function, and the range of the original function becomes the domain of the new function. So here's our two videos. I'm just going to click through those. Table of domain and ranges. Okay, so this table is going to be your friend. You're going to have to draw one of these every time you get one of these composite function questions. If you're going to ask a question, the first thing anyone's going to say, or I'm going to say, is, have you drawn the table? So let's have a look at a couple of graphs. F of x, 2x minus 1. So that's just a straight line. It's going to do something like that. And g of x is 3x squared. So that's going to be a parabola that looks something like that. So our domain of g, if it's a parabola, is all real values, and the range can just be above 0, isn't it? So it's going to be all real values, but it does include 0. Because it's a straight line that goes like that, r and r, they're both r, all real numbers. So these are your new best friends, as I mentioned. So you're going to have to work on that yourself, okay? So you're going to have to look at this exercise, work through it, but hopefully this next bit will help you a little bit. And this is if you need to, you can ask some questions on Google Classroom. Type lots of stuff in, not just memes about giving people kisses. So we can see that the FOG, so the function going this way, would not be the same as the function this way because we have different ranges there. So let's look at an example. State if fog and goth is defined. So what do they mean by this? So there is a possibility sometimes where you can't do, can't work out a composite function. So I'll show you that here. So here's our table. G, straight line, so it's all R values. Square root graph, we know a square root graph looks like this. So all real values, positive real values including 0, all real positive values including 0. So here's a tiny little graph so we can see that visually. So we've got the table here and we've got the graphs visually. So the range of f, which is this, is a subset of the domain of G. So we know that that will be part of that. For the range of G, so where's G? The range of G, which is this one, no, the range of G, which is that one, sorry, is not a subset of the domain of F. So all real values aren't also all positive real values, because this here, this includes negative numbers, this one doesn't include negative numbers. So GOF is defined, but FOG is not defined. So we're going to look at an example in a minute. Now, in a little bit more depth. So again, this took me ages. I hope you love it. So here's the two graphs that we just had. Graphs a little bit bigger, same table. So we can see here the range of F. So the range of F. So this is F. Here's a function F. The range of F is all of this, isn't it? So the range of F is just all positive numbers, including 0. And we're going to map that now onto the domain of G. Okay, so that maps onto the domain of G. We can see the domain of G is all of that, so it fits perfectly onto that. It's actually, we've actually got more than that, so it fits easily into that. So we've got a tick. That one works. Let's look at the other one. So the range of G, so here's G, the range of G is all real values. There's the range of G. So if we now map that onto the domain of F, we can see, whack, oops, we don't have this bit. We don't have this bit. So it can't exist. So watch that a few times if you need to try and get your head around what went on there, yeah? So not the range of G is not in the subset of the domain of F. For the functions, state why it's not defined and state the restriction. So let's set this up first. So domain of F. So there's F, domain of F. So this is going to be a quadratic. It's just going to drop below the x-axis, isn't it? So the domain is all of those values. The range goes from -1 to infinity. That's a way of writing it. So it's going to be a quadratic like that, but it's going to be just below the x-axis. And we know this, square root graphs, we know that one as before. But again, you're going to have to work through this yourselves. You've just seen how we worked it out previously, so you're going to have to work on this one on your own. Textbook will help you, and of course, you've got plenty of time, so you can use the internet, all sorts of things to help you. So composite function. So we can see the range there. That one's got a -1 there. See, we've got an x squared -1. So we can see maybe if we square root that and that, we can get that. So have a bit of working on that, yeah? Section summary. So this is just all the notes that we've had, Sometimes that we've had a look at that. In general, that doesn't happen. So some work for you to do. And as I mentioned, I think it was Jess was already onto this. There are 12 questions, lots of work for you to do. We haven't got another class until Friday, and you guys have got so much time on your hands. You must be so bored. So do enjoy doing some maths and get onto Google Classroom and ask me some questions.